I just wanted to thank our presenters. So we have two speakers today, Dr. Haddas and Dr. Perez. And just to give a quick introduction, Dr. Haddas is the director of the Spine Biomechanics Lab at Texas Back Institute. He's built an advanced motion analysis laboratory that has allowed the Institute to capture valuable information about the spine. They've undertaken important research that has had a significant impact on analysis and treatment of commonly performed spine surgeries that are carried out at their center. So in particular, Dr. Haddas' lab quantifies patients' functional abilities, such as walking, balance, lifting, sitting, and other activities. The lab has evaluated over 600 spine patients at different time points during their treatment, and Dr. Haddas works closely with orthopedic surgeons, pain management physicians, physical therapists, and other clinicians. Dr. Haddas has published a number of publications in peer-reviewed scientific and medical journals, and he's very active in presenting his work at national and international meetings. Based on his extensive work, Dr. Haddas was recently named to the inaugural 20 under 40 list by the North American Spine Society's publication Spine, and this is in addition to several other research awards that he's received. We're lucky enough to also have Dr. Perez joining us for the latter part of the presentation to provide a physical therapist perspective. So Dr. Perez is a physical therapy manager in Plano, Texas. She has 25 years of experience as a physical therapist, and she obtained her doctorate in physical therapy in 2011. Dr. Perez currently serves on the exercise committee for the North American Spine Society and has authored several chronic pain and spine-related articles, and she also presents her research at local and national conferences. Dr. Perez was winner of Living Magazine's 2019 Top Physical Therapist, and she's passionate about providing great care and education. So thank you both for being with us today to speak. And without further ado, I'll pass things over to Dr. Haddas to start his presentation.
Okay, thank you, Cindy, and hello, everybody, and thank you for joining us. Before starting, I have to disclose I do have a financial relationship with the following entities. So here are the objectives for today. So at the beginning, I'll start with the fundamental and speak how do force plates work and what we can actually measure with the force plates. Then we'll talk about the pros and cons of having a force plate by itself at the lab versus a full equipped lab with many tools. Then I'm going to actually talk about the clinical advantage or the challenge to quantify the functions and what we currently use to quantify the balance test or other functional tests. And then we'll see how a force plate actually can help us to quantify balance. So let's start off with the question, what is a force plate? So force plate is measuring instruments that measure the ground reaction force generated by a body standing on or moving across it, right? Force plates allow us to quantify balance, gait, landing, and any other biomechanics parameters that we want. The most common area of application for force plates are medicines and sports. So force plates use of several different types of sensors to measure forces, and the corresponding value usually are in newtons. So beyond the vertical force, some force plates can measure shear forces, but I mean forces in the anterior and posterior direction and side-to-side directions. These come into play more specifically for healthcare and research applications, such as if you're feeding patients with orthotic bracing, or if you study a specific neuromuscular disease. So if you're looking on sports, if you're looking on any cutting maneuvers, like a crossover in basketball, or change direction in football or soccer, or even a baseball pitch. Let's look on how do force plates work. So force plates use transducer to measure three-dimensional or vertical forces that apply on them. There are several types of force plates on the market, and they all, they're all classified either by how many pedestals they employ, we have a single and multi-part, or by the type of transducer. Although these sensors function differently from a technical standpoint, they all measure force by monitoring electrical currents flowing through the sensors and absorbing and recording its changes as the forces apply, basically. Then we look on the changes for the calibration, and we know how much forces are applied. So what we can actually measure with the force plates. So force plates can measure ground reaction forces. So if we know the frequency of the force data, we can then perform additional measurements that provide us with far more information about the human movement. And with some basics math, we can use this information to calculate the following. We can look on velocity, so how fast is the patient's gait is, or how fast the center of pressure sway. We can look on displacement, so how fast they're walking, how fast they sway, how long is the eccentric phase during landing, for instance. We can look on temporal parameters, which is usually looking on cadence, stance time, swing time, double support time, and other. We can measure powers. It's basically the amount of torque and work is done by a specific joint, and I'll discuss about it more in the next slides. And more clinically important, we can look on symmetry and asymmetry between patients. So in case we have two force platforms, we're able to measure each leg forces independently. This is very useful when evaluating patients with deformity or patients with radiculopathy when they have a severe leg pain on only one side, or more common patients with unilateral hip or knee osteoarthritis. So let's talk in more detail of what we can measure. Let's start with the ground reaction force. So ground reaction force is the force exerted by the ground on the body in contact with, and this is based on Newton's third law. One thing we can use ground reaction force is to calculate coefficient of static friction by simply dividing the magnitude of the friction forces by normal forces. Another thing we can measure with the force plates is a center of pressure. And the center of pressure is the point where the total sum of pressure fields acts on the body, causing a force to act through that point. So the total force vector acting on the center of pressures is the value that integrated vector of pressure field. Another cool things we can get from a force plate is the joint moment. And a moment is a turning effect produced by a force. It's often also called torque. So torque can be thought as the rotational analog of the linear force. We can calculate torques by multiplying the perpendicular force by the distance from the pivot or from the axis of rotation. Another things we can measure from a force plate is joint power. And power is defined as the rate of work or the rate of energy flow. Two parts measurement can be obtained from a joint kinetic. We can look on the joint power or the muscular power. So now, when we know what the force plate can do for us, let's look on the pros and cons of having the force plates as independent tools or a part of a package, basically, a part of a whole lab package. There's ongoing debate, and it's actually a big debate, on how many tools are actually required to evaluate patients' functions. As the more tools is the better, or these days we actually see that our phones and our smart watches actually can get some of the spatial pulse measurement that we have. What about the spacing? If we have a small clinic or a small lab, can you fit a lot of tools in these labs? And what if you have a budget restriction and you cannot spend a lot of money? So let's talk about those. So first, let's start about using a force plate alone as independent tools. So the first process that I can see that a force plate is very easy to use. I mean, beside the setup, it may take some time, but it's usually done by the force plate company. To work with the force plate is very easy to use, and troubleshooting is very rare. A second concept of using a force plate by itself is that there's no need for long preparation. We don't have any markers involved. We don't have any stickers. Minimum calibration is needed, which makes everything much more easier. And on top of that, most of your staff member can probably run it and use it for this testing, which is good. Recently, we see more and more studies show agreement between motion data and muscle activity data to a force plate data. So we see a high correlation with the force plate data to kinematics and EMG data. Now let's talk on a force plate as a part of a lab. It can be going along with the human motion capture, with the pressure mat, with EMG sensors, IMU, you name it. So the first cons, and this is kind of a personal perspective, I mean, the more data I have, the better, right? So it's better to use a force plate data with kinematic and EMG data in order to better understand the whole picture. A better understanding of the muscle activity, center of mass location, and range of motion can put more light on the global pictures. This can help me and us basically to better understand and explain the surgeon and the surgeon and the patient itself, what's going on with the patient's functions. Now, whenever you have a lab with a lot more tools, you do need more manpower, and usually is require engineering to run all these tools, right? Usually the staff that you need is required to be a higher level of education. They need to be a kinesiology students or engineering. Another cons for having a force plate with other tools is that when you have more tools, your budget gets much bigger. So you have to spend more money, right? Now you have to buy a force plate and a human motion capture and an EMG and a pressure mat, etc. Now, having a lot more data, which is good from one hand, also requires from you more time to analyze the data. For instance, in my lab, after we finishing see the patient for an hour, we're literally spending an hour to 2 hours just reducing all the data and get it ready for presenting for the patients and the surgeon. So after we cover all the fundamental of the force plates and the tools, let's switch gears and talk about clinical stuff for a little bit. So in order to maintain normal balance, a complicated system of the sensor neural and the musculoskeletal pathways has to contribute. This system includes the vestibular, cerebellar, peripheral sensory, structurals, and motor systems. Neuromuscular disease, for example, myelopathy or Parkinson's, can impact static and dynamic balance through our unique intersections of the sensory, structural, and motor pathways. Measuring dynamic and static balance in a clinical setting and understanding their impact on patients' outcomes has remained challenged due to the nature of the data and all the systems that are involved. By having the ability to quantify the center of pressure, the ground reaction force, and moment measurements, I mean, this is maybe our solution. So the next 20, 25 minutes, I'm going to try to convince you guys how a force plate can help you to fill up this gap. So let's talk about balance for a little bit. There are several factors that can predispose a patient to postural instability, which can alter their balance. You may know some of the factors, but there are aging, vestibular deficits, poor vision, spinal disorder that can cause changing in posture, and weak core and leg muscle activity. When one balance and functions are determinately altered, it can have profound effect on the quality of life and activity of daily living. Now, if you take into my word, and when we compare it with a healthy control, patients with spinal disorder demonstrated an increase in postural sway and greater difficulty adapting for a changing condition. Moreover, whenever those patients losing their balance, it's really hard for them to recover from this loss. By definition, balance is a measure of the postural stability and the ability to maintain center of mass with a minimal sway. Postural control is the ability to maintain or return the body to the state of equilibrium or balance. A complicated system of the sensor neural and musculoskeletal pathway need to contribute to maintain the balance. And then I mentioned all those systems before, which including the vestibular system, cerebral, peripheral, sensory, and the motor system. And again, using patient's example, the spine actually impacts static and dynamic balance throughout a unique intersection of structural spinal alignment when sensory and motor pathways. Now let's talk about balance compensation strategy. The postural control system uses distinguished strategy on how to compensate. The first strategy is ankle strategy. Ankle strategy involves postural sway control from the ankles and the feet, and as you can see in the picture. The second strategy is a hip strategy, which involves postural sway control from the pelvic and the trunk. And the last strategy is the suspensory strategy, involving adjustment of the center of mass toward the base of support by flexing both of the legs or slightly squatting motion, as you can see the picture over here. Now let's look at 2 examples of real patients. The patients of the left are obviously using the ankle strategies. So you can see how she sway, but how most of the motion actually coming from the ankles and the feet. The patients on the right using more of the hip strategy, the pelvic, and you can see how she's trying to maintain balance by flexing more the hips and using the pelvis. Let's look at more example of altered balance in spine patients. So there's some factors that can foster in the multiple ways by different pathology. For instance, let's look on cervical myelopathy patients. In cervical myelopathies is a compression of the dorsal column of the spinal cord, which cause a critical loss of proprioception. If you look in an adult degenerative scoliosis basically, the scoliotic spinal alignment affect the body's center of mass, and those increasing the energy expenditure of compensation and the muscle response. Other pathology like degenerative lumbar spondylolisthesis or single-level lumbar denervation, which both usually include radiculopathy, may also have effect on the balance via alter of the spinal pelvic ratio imbalance or somatosensory impairment. Now let's talk about common balance tests. There are several ways to measure balance. Evaluation based on a self-reported questionnaires regarding the activity levels and fall history are commonly used in the clinic settings. These surveys are quick, cheap, and visible and used in most of the clinic. Other functional evaluations such as the Romberg test, time up and go, the BEST, which is the balance error scoring system, the STAR exertion test, and other are commonly used in a clinical practice as well. Now, when we're looking on the laboratory setting, like a biomechanics lab or a gait lab, those are able to provide us more detailed information, such as sway level, center of pressure, the cone of balance, or the cone of economy dimensions. Now let's spend some couple minutes talking about the cone of economy or the cone of balance. So Professor John Debussy first introduced the concept of cone of economy and balance in the mid-90s. He defined our body as a stable region of standing postures. His underlying assumption was that if a patient deviation outside the cone, this is challenging his balance mechanism and he consumes more energy. Now, the term cone of economy is commonly used when assessing balance in deformity patients. So when I went to my first spine conference, was about 5.5 or 6 years ago, I heard everybody using the term cone of economy. So I simply raised my hand and asked the question, so what is a bad or good cone of economy look like? And then the answer I got is, okay, if they sway a lot, the cone is big. So I asked him, what is a lot? So how do you actually quantify that? And I didn't quite get the answer I wanted to hear. So I went back to my lab. And then what we did, we actually developed a method to quantify the cone of economy using the tools I have, using three-dimensional motion capture, forklifts, and EMG data. And we published this paper 3 years ago. These techniques allow us for a patient-specific characteristics of the sway and effort parameters. And since then, we use it on different spine conditions. So this analysis can objectively quantify the dynamic balance, and we publish several papers on different cohorts. So how we did it? We brought the patients to our lab, basically. We have the patients standing on 2 force plates. We place all reflective markers on them using a human motion capture and EMG sensors. And then we try to mimic the Romberg test. So we had them to stand with the eyes open for a full minute. and look and think. And then what we did, we actually modeled their cone of economy, three-dimensional. So we modeled the base of support, as you can see in the bottom. We actually look on the center of mass, as you can see in the middle ring in red. And then we also modeled the head sway, as you can see on the top ring. And then by doing that, we're actually able to make a patient-specific cone of economy. Now, the next step for us was to actually quantify that and look on some numbers. So what we did, we took a 2D view from the top, so from the head basically looking down, and then we plotted, as you can see in the figure here. And what we did, first of all, we calculate the range of sway. So the line is actually represent the head or center of mass motion and how much they're moving during the minute. So what we did, we calculated the range of sway. So we see how much, what is the peak, the sway to the left, how much to the right, and then we actually quantified it and defined it as the coronal range of sway. We did the same thing for the sagittal and for the vertical. Then after that, we took actually the spaghetti line over here, or basically how much this patient's move, and then we stretch it and measure the length of this sway, and then we call it the overall sway or the total sway. But then, so after publishing a couple of papers and presenting this in several meetings, we realized that sending patients to a fully equated gait lab with, a human motion capture, force plates, and EMG is not always feasible. So we asked ourselves the following questions. How we can actually predict the cone of economy using only one tool, or in this case, we actually test how we can actually use a force plate to predict the cone of economy. So what we did, actually, we look on, we did a study at Texas Vet, and we look on 423 spine patients and 50 healthy controls. And this is, you can see the demographic over here in the table. And we try to age match the health control for the age match control to the other patients. And what we did, we had all these patients and controls performing the balance test that we saw in the video a couple of minutes ago. And then what we draw some data from the force plate, looking on the center of pressure, sway in both in 2D direction, and the overall sway of the CO, center of pressure. And then we also look on the head sway, our measurements from the cone of economy. So we got, also in this paper, what we did, we actually break it down to spine patients only, if you want to use it for your spine patients, or if you want to use it for healthy control, we actually create the same table just for the healthy control. Then the first thing we did, we ran a correlation between the two sets of variables. As you can see here, we find a very strong correlation between center of pressure to the cone of economy measurement. They can see that about 90% of the cone of economy variables variance can be explained by the center of pressure predictors, which is we're really happy about this result. Here it's just a scatter plot of the head total sway on the vertical axis over the center of pressure overall sway. And again, beside a few outliers, the data actually falling in a straight line. So then what we did, we ran a linear regression model to predict the cone of economy for the center of pressure variables. So what we did, first of all, we generate one general equation that we use the whole 473 patients. And then we have a second and third version, just one just for the spine patients and one for a healthy control. So in this equation, we're actually trying to predict the head overall sway, the length of the line over here, basically, of center of pressure variables that we got. Then we did the same thing for the head sagittal sway, the range of sway for sagittal plane, and then for the coronal plane, the same thing. We did one overall equation, one only for spine patients, and one for a healthy control. So in other words, we can use the center of pressure variables to predict how big or small our cone of economy is going to look like. Now, for those of you that are not engineering in the crowd, we actually generate a nice spreadsheet that you can just plug in. You can go on a force plate, and then you plug in your force plate output in this spreadsheet, basically. And this is you get directly from the first place. And then based on that, you can get all the estimated cone of economy measurements. You can get it for everybody together. You can use the equation just for the spine patients, or you can head your data for the healthy control. So now on a different study, right, we start to compare between different cohorts. So we explore the cone of economy and the center of pressure for different spine patients cohort. And in this example, we'll look on lumbar spondylolisthesis patients, as you can see on figure A over here, and you can see the cone of economy and how much they sway. We look on adult degenerative scoliosis, as you can see in figure B, and we look on fell-back syndrome. These patients are patients that have multiple back surgery that actually failed, and the last resort is put a spinal cord stimulator in them. So this is what we look on this cohort as well. And just for comparison, we have healthy control. So here we can just basically appreciate, I mean, how much this patient spending energy, how big are the cone of economy is compared to a healthy control? How big is in the cone of economy dimension is compared to a healthy control? So if we have patients coming to you and said, hey, this is very hard for me to stand and it's making me very tired. Now, do you know why? Now we can have the tools to explain why they're so tired. Because look, they're using 2 to 3 more times energy just to perform the same test like a healthy control. Now, what we did basically after that, we look on the relationship and distribution of the scores between cone of economy and center of pressure across all cohorts. So what we can do over here, we see different cohorts, and we can see how much is sway, and just look on the normal distribution for each of these. Now let's go back to my questions. If you remember the story I told you from my first spine conference, it was in 2019, and I asked basically how bad or good cone of economy gonna look like. So fast forward 6 years, we actually did a study on that. And in this study, we actually proposed a classification system to distinguish between clinically severe and moderate changes in balance. So here, what you can see distribution between the severity in the coronal sway, here, the sagittal sway, and the overall sway for spine patients. So this is going to help us to actually pinpoint how our patients are doing before and after intervention. This is also a good method to classify them into a balanced severity level. So let's say you have patients coming in, basically, and you do the balance test or the COP test. Basically, you can actually get a score and tell the patients, okay, you are here on the scale, you are on the severe scale, or you're on the moderate scale. So in addition to that, and in the same study, we want to look actually if patients reported outcome scores, and in this one we look on the visual analog scale for the low back pain, the visual analog scale for the legs, the ODI, which is a functional questionnaire, and the TSK, which is the Tampa scale for nikisinophobia. All of these questionnaires asking the patients basically how much pain do they have while they're standing, or how much for the TSK, how much they're afraid to move because of the pain. So we try to look on the relationship between the PROM scores to the balance severity classifications, right? As you see, we didn't find any good relationship over here, but just to give you a side note, in previous studies that we did, we found a weak to moderate correlation between what patients actually reporting about the pain level or how much they can move to what they're actually moving using a force plates, human motion capture, and EMG. What this is telling us that actually there is a big need for objective tool to quantify patients for these patients, because obviously we don't see a relationship between what patients are reporting to us to what is actually happening with them. So to summarize this lecture and kind of a take-home message for you guys, we see more and more studies that show there's a high agreement between the kinematic data to the force plate data. So in other words, a human motion capture has a high relationship to our force plate data. And this is we saw specifically in the cone of economy and the balance scores. I'm not saying that all those tools measuring the same thing, but they are finding a similar result. So if somebody performing really bad and you see bad results in special controls, you're most likely to find a bad results using a force plates or EMG as well. I also present to you a good study that we are able to predict cone of economy and balance measurements using only a force plates. This is also good because now we can have more and more clinics and scientists quantified their patients' balance and cone of economy and classify and using our classification method to determine if they are severe, if the balance is severe or moderate. Now, if you have a strict budget or a limited space, a force plate can actually use as a standalone device, and we saw it today that we can actually use a force plate itself to measure the measuring balance. So if you do have a limited budget, or do you have a small office or a small space that you want to use, and you think what to do with the money, I mean, force plate may be a good solution for you. Based on today's lectures, we saw that force plates is much more objective tool for measuring balance compared to a traditional balance test using in our clinic or by physical therapy. With the force plates, we can diagnose if a patient has a large or small cone of economy dimension and center of pressure and compare it to a healthy control and to see how severe it is, or just look on the effect of medical intervention. If it's a surgery, if it's a physical therapy, heat, ice, medication intake, rest, exercise program, you name it. We can run the test before and after all those interventions. So to sum everything up, for my opinion, surgeons and clinicians should consider having a force plate in order to diagnose and track their patient's balance and recovery. So now let's have a clinician point of view on this topic. So it is honor for me to introduce Dr. Yoheli Perez. Dr. Perez is a physical therapy with over 20 years of experience treating patients with a variety of disorders. Like Cindy said, Dr. Perez has wide research background and work a lot with force plate data. Now, I'm going to ask a couple of questions of Dr. Perez. Yoheli, are you there?
Yeah, can you hear me okay?
Yes, perfect.
Okay, cool, great.
So let me
Thanks
start
for
with
the introduction.
So let's start with the first question. So for your opinion, how a force plate can help you to distinguish between balance dysfunctions?
Well, first of all, force plates can be an objective tool that show what the clinician's eyes can't see. So it definitely magnifies what we can't see. It can provide an accurate number or score for the test performed. You can distinguish between different balance functions by the range and the speed of the sway, how quickly the center of pressure line is moving, slow sway compared to quick sway, small and quick, as you mentioned with the myelopathy, compared to big and slow, as we've seen with chronic low back pain and deformity. And if you have two force plates, you can analyze the symmetry between two sides, especially great with deformities, SI dysfunctions, hip OA, ankle instability. And you definitely see this often in literature and practices with knees and ACL reconstruction rehab.
Thank you. Kind of following this line, what do you think, for your opinion, what are extra data you can get using a force plate compared to the traditional balance test that you're using in your clinic?
Now, I know you've already gone over a lot of this, but I guess to sum it up, on what I'm getting from it is that you get the ground reaction force, you can get the sway length, you can get sway range of motion, you get the sway speed, you get the center of pressure, you definitely get the cone of economy dimensions you brought up. And I like that you can also use it for landing dynamics, as with jumping and getting power out of it. You can also see how a patient applies the force when accelerating or decelerating, which is kind of neat because you can do quick and repeatable measurements during the movements, which is good for training. I like that you can get a baseline to monitor subtle differences, and I love that you can get those asymmetries detected that sometimes you might not see with your eyes. And again, the most important thing is that it just gives you an accurate value for each test. The tests are easy to take, and you can do it, before, during, or after the PT session if needed. And I know that TBI has used it before and after the intervention and tracking of their rehab progress for almost 2 years or up to 2 years. I also know that people do use it for return to play too.
Right. So do you feel that using a force plate is more accurate compared to what the common balance testing that out there?
Yeah, I see it. It's like taking a heart rate versus an EKG. You just get a lot more information from it. So say you have the timed up and go test, which is a great test. I love it. You do get great information, but with the force plate, you get to have quantitative data on many areas, which, what's nice is you can even go back later to check something out and analyze it, especially if you see a certain trend. And maybe you might have missed something. You can always go back and see it objectively and with specific data. The cool thing also is that there's no changes between evaluators. You definitely have the same scores every single time.
Okay, the last question for you. So how a force plate can help you in your clinic?
Well, like you mentioned earlier, it's really easy. You can just place it on the floor at the entrance of your clinic or somewhere else. It's not a huge bulky piece of machinery, which is nice. Then if you have it, say at the entrance, you can have every patient just step on it before starting sessions or for that quick balance test. And if you do it with every single one of your patients, now you have a really huge database for your clinic, which is great for marketing purposes, as well as it definitely will support PT practices in general, as far as like just making us more evidence-based in general.
Great. Thank you very much, Yoheli, for
welcome.
your opinion. Now I'm going to open the floor. I'll forward to Cindy and open the floor for questions